All right, let's go through a tangent line approximation problem. On this one, though, we are given a cube root function. So quite a bit going on with this one. What we want to do is we want to find the tangent line to this function at the value of x equals 1. All right, so I'm electing to use the point slope form of a line. So y minus y1 equals m times x minus x1. So to use this, what we need is we need a point and we need a slope. To find the point, what we're going to do is we're going to substitute 1, our x value, into the function. So we're going to evaluate the function at 1. So we have the cube root of 45 minus times 1 cubed minus 18, which is going to work out to be the cube root of 45 minus 18, which will be the cube root of 27, which works out to be 3 because 27 is 3 cubed. And when your exponent and the index on the radical match up, it's going to work out that stuff cancels out and you're left with the base. So at this point, we have an ordered pair. We plugged in a 1 and we output a 3. So that's going to go as our x1 and y1 when we plug into our point slope form of a line. But next, what we want to do is we need to get the slope of our line. To get the slope of the line, the slope is going to be equivalent to the derivative when we evaluate it at that x value of 1. So we need to calculate the derivative next. To do this, what I'm going to do is I'm going to visualize this as, instead of being a cube root, I'm going to write this with a fractional or rational exponent. So the cube root can be rewritten as raised to the 1/3 power. All right, now to take the derivative, we're going to have to use the chain rule and the power rule in conjunction with one another. So we're going to bring the exponent down in front. The 1/3 comes down. We're going to keep the inside function the same. So 45x cubed minus 18 remains the same for now. We're going to reduce the exponent by 1. So 1/3 minus 1 makes negative 2/3. And then we have to multiply this by the derivative of the inner function. So the derivative of 45x cubed, we're going to bring the exponent down using the power rule. So 45 multiplied by 3 is going to be 135. We reduce the exponent by 1, so 3 minus 1 makes 2 for our new exponent. And then the derivative of 18, a constant, is going to be 0. So I'm going to leave that off. All right, so now we have our derivative. I may rewrite this derivative real quickly so that we don't see that negative exponent. So what we can do is that 1/3, the 3 will remain in the denominator. I'm also going to go ahead and move, instead of having the negative exponent, move that down to the denominator. So 45x cubed minus 18 raised to the positive 2/3 power. And then the 135x squared, I'm going to leave up in the numerator. All right, so we've calculated the derivative. Now we need to evaluate this derivative at an x value of 1. So f prime of 1 is going to be 135 times 1 squared all over 3 times 45 times 1 cubed minus 18 raised to the 2/3 power. So 135 over 3 times 27 raised to the 2/3 power, which when we put this into our calculator, we're going to eventually get 5. All right, so remember that was our slope is going to be 5. So we have our point, we have our slope. Let's plug into the point slope form of a line. So we can say y minus our y value of 3 equals 5 times x minus our x value of 1. And I'm going to go ahead and put this into y equals mx plus b, the slope-intercept form. So to do so, I'm going to add the 3, move that to the other side. Do a little bit of distributing. So 5x minus 5 plus 3. Combine those like terms and we have 5x minus 2. That's going to be our tangent line to this graph of f of x at this given point. So we can say we can approximate f of x by using 5x minus 2. Next, let's use this approximation, this linear approximation, to approximate f of 1.1. So to do that, what we need to do is plug in 1.1 into this approximation that we just found. So we're going to take f of 1.1 is going to be 5 times 1.1 minus 2, or in our case, that'll be 5.5 minus 2, works out to be 3.5. Let's next compute the actual value of f of 1.1. So f of 1.1, the actual value is when you plug into that cube root function. So we're going to take the cube root of 45 times 1.1 cubed minus 18. That was the original function I'm just plugging back into. Get the calculator out, and this is, maybe I should say approximately, I'm going to use equal signs for now, but it works out to be 3.473127539. All right, last thing that we're going to do is we're going to compute the error between our approximation, the tangent line approximation that we just calculated, and the actual value for this linear approximation. So a quick subtraction, we're going to do 3.5 minus that 3.47 dot, dot, dot. And this works out to be 0.2687246. And typically when we do this, this error, it's an absolute value. So whichever one you subtracted from the other, you're going to take the absolute value of that, and it's going to be a positive error. All right, hope this helps out. I know this is a kind of tricky problem as you're doing tangent line approximations. Just take your time as you go through it, especially if you're doing a linear approximation like this. I use the point slope form. You could use slope intercept from the beginning, but you really need to figure out a point by plugging into the original function. You need to calculate the slope by calculating the derivative first, and then plugging your x value into the derivative, and then use the point slope or slope intercept form to get your approximation, your linear approximation or tangent line approximation. All right, hope this helps. See you.